Hey folks, so for this Grasshopper lesson we're going to be going over how to create some images like Doomscape created by Shop Architects from MoMA PS1. So we're going to be reviewing some contouring methods where you take complex surfaces and contour them to produce line work, to produce CNC millable parts and pieces, and so we'll kind of look at that whole process for these scripts. So we'll produce a couple images similar to these, and we'll get kind of into the workflow that Shop used for something like this. So let's hop into it. Alright, so I've got my Grasshopper file open here, and I've got my Rhino file open. So in this Rhino file, let me just close out of Grasshopper real quick so you can see what we're working with. But we're going to start out by contouring some open surfaces that look a little bit like this. So we'll start with some faceted surfaces, then we'll move over to some more complex surfaces that have smoother contours to them. And deal with creases and things like that. We'll get into a different method of contouring for this type of surface. And then we'll also get into contouring some more complex three-dimensional massing models. And then from there, we'll get into producing all of the line work that results from those contouring methods. So you can get hyper-dense line work that explain different types of surfaces. These are elevations taken by contours through the first two surfaces, and then we'll get into some filleting. And then these are some images that were produced from the massing models. So contour is a really interesting way to produce line work that explain three-dimensionality through a flat 2D image. So we'll go through that whole process, and then we'll export the line work out to an Illustrator file and produce our drawings. So I'm not going to really get into how to create these surfaces. There are other tutorials that I've created that will go over things like this, but these are the surfaces that we're going to be using for this tutorial. So if you want to check out, how to really manipulate surfaces in Rhino, go check out that tutorial. And then jump back into this one when you've got some good control over the surfaces that you want to make. So we're going to pop open Grasshopper, and I've got a couple different ways or methods of contouring set up here, so we're just going to kind of go through each one of these and rebuild each one step by step. So I'm going to turn all of these off. And if you're at a beginner level, turning groups of components on and off is just middle mouse click, hide or disable preview. So we'll just start with the top one first. Actually, you know what? I'm going to switch these two. So I'm going to start with this one first. It's a little simpler. Pull that over there. Turn that off. Okay, so we'll start with this one here, which is pretty much just a simple contour method. So I'm going to hide these just so they're out of the way. And let's take a look at this surface. So first and foremost, I'm going to turn off our end preview here. This is a single surface, even though it doesn't look like it. This is not a poly surface, even though you see all these lines going through it. I can turn those off by coming into my properties and turning off show surface ISO curves, and you'll see that it's all one continuous surface. Again, if you go through the other tutorials on Rhino surface modeling, you'll understand what the difference is, but just want to make sure you guys understand that that is one single surface and not joined surfaces that create this shape. And so what we're going to want to do is, because we're going to be contouring this surface, we're going to reference it into Grasshopper. So I'm going to double click, type surface, click that, select it, right click, set one surface. Now you can already have your surface selected or deselected, it doesn't matter. I'll do set one surface. Grasshopper is going to minimize. I'll click on the surface that I want to reference, and then that surface is going to turn red, which means it's now referenced in Grasshopper. And at this point I can hide the Rhino geometry. So I'm just going to select that, type hide, and now I've got my surface referenced into Grasshopper. And then the next thing we're going to do is grab a contour node, which is going to tell Grasshopper to contour the surface in a direction that we define, and we're going to provide a distance between each contour line. So we're going to type contour, and we want this contour a set of B-rep or mesh contours. So we'll click that. Now for any Grasshopper file, you have inputs and outputs. So our inputs, it's asking for a B-rep or mesh. A B-rep can be any type of geometry that you create in Rhino. So it can be a surface like this, it can be a poly surface that's more complex. Right now we're just going to use this surface. So I'm going to hold down, click and drag, left click, and snap that in. So our surface is now referenced. We have one value, which is from one source, which is our referenced surface. And again, if you just hover over these, it'll pop up a description of what each one of these inputs is. So that one value referenced from one source is our surface that's referenced from that node. Our contour start point. You can probably just leave that blank. By default, it's going to make it 0, 0, 0, which is what that little red X is. I would just leave it there for now. You can set it to a custom point if you want. So I can create a point in Rhino. Grab a point node in Grasshopper. Right click, set one point, click that point, and reference it. And now I can move that point around wherever I want. Doesn't really make a big difference when it comes to contouring, but it can be helpful sometimes. For now, I'm just going to delete it and leave the default at 0. Contour normal direction. This is the direction in which we're going to contour. So if we come back up here and I turn on this, you're going to notice that the contours are running left to right, which means this object is being contoured in the Y direction. Look at your little axis down in your left hand corner. You're contouring in the Y direction. So you're slicing it, moving in the positive Y axis. So what we're going to do is we're going to double click and grab a Y unit, which is a vector in the Y direction. And we're going to plug that into N to tell it to contour in that direction. And then the last thing it's asking for is a distance between the contours. So that's literally the distance from one contour to the next. And this is going to be based on whatever units Rhino is set to. So if I type units, I'm set to millimeters. So right now this is like a really small object, and there's only 1 millimeter between each contour. So depending on what project you're working on, you just want to make sure you're working at the right scale. I didn't really care, so I just stuck with whatever the default was. But to apply a unit to this, we're going to double click, and to create one of these sliders, all I'm going to do is type 10.000, and that's going to give me a slider when I hit enter from 0 all the way to 10, and it's going to give me those decimal points. Now I can double click this, and it's going to open up a sub menu, and I can change the maximum value the slider can go to, the minimum. You can change how many decimal points are located. If that helps, you can change it to odd numbers only, even numbers only, round numbers, so no decimal. But for now, we're doing a distance, which accepts, you know, if I want to do like 1/2 millimeter, I need the decimal points, so we're going to leave it like that. And then I'll just plug this into distance. And so I'm going to come up here and just turn that off so you can see what's going on. So right now this is being contoured at 10 millimeters. So if I wanted more contours, I need to shorten the distance between each contour. So I'm going to drag this down, and my contours will become more and more dense. Okay. So I had this at around 1. It's a pretty good density, so I'm just going to stick with that for now. Okay, so the next thing we're going to do is, now that we have our curves set up, we're going to go through and I'll show you guys how to give this some thickness. So if you look at the final output, each one of these contours is turned into a slat. And the intent is that you could CNC mill each one of these slats and line them up and produce that same effect like Shop created for their MoMA PS1. So that's going to be sort of the next step in this process. So there's a couple things we're going to do. First, we need to give some thickness or offset each one of these curves so that these slats have some depth to them. So in order to do that, the first thing we're going to do is grab the end point of every curve. So this is just our end points node, so double click, type end, and you'll get end points. And when you plug all of your curves into this endpoint node, you're going to get the endpoint of every single curve. Okay. The next thing we're going to do is we're going to offset these curves down or inward to give our slats some width. And that's going to be done with an offset node. So I'll type offset, and I want this offset curve. I'm going to come in here, and I'm going to offset every single one of those curves. Now by default, they're kind of offsetting in all different directions. You'll notice some go down while others go up. So we want to resolve that by defining a really specific plane that we're going to offset these in. So when you offset something, you have to define a plane. So one example, by default, the plane is our XY plane. But I want them to offset up or down in a single direction. So I'm going to switch this to, instead of XY, I'm going to flip this plane 90 degrees, and I'm going to offset them in the ZX plane. So I'm going to just double click, type ZX, and I should have a ZX plane pop up. Maybe XZ, yeah, there we go. So I want this XZ plane. So it's going to ask for a distance, we'll do that in a minute, but for now I want to plug in our XZ plane to P. And what you'll notice is that just resolves any of the weird offsets, right? Everything is now offsetting in the downward direction. So if you look at kind of this front curve, it's being offset downward. Okay. The next thing we want to do is define a distance. So again, I can type 10.000, hit enter. I'm going to turn this down because I know 1 is about where I want it to be, so I'm going to plug this into distance. And now you can change the offset distance, or what would really be the thickness or the width of each slat. So you can mess around with that. But again, 1 is about where I want it to be, so that's where I'm going to set it. In order to type in a specific number, you just double click and type 1. And that's all we're going to do with that. So that gives us our offset curve. Then we're going to take the endpoints of those curves as well. So I've got two series of endpoints. Right, I have the start and end point of our top curves. And then I have the start and end point of our bottom curves. And I'm grabbing those endpoints because we need to complete the curve all the way around, so it's a closed curve. So right now this is open, and this is open, which means I can't extrude this to be a solid shape right now. It needs to be a closed polyline all the way around. So we need to draw a line from that point to that point, and from that point to that point. So what we're going to do is type line, and you want to get this create a line between 2 points. So we're going to go from the start point of our top curve to the start point of our bottom curve. So start point to start point. That's actually going to be this one over here. So you notice I just created that little vertical line. Then we're going to do the same thing. Let's type line, grab our create a line between 2 points. And this time for the other side, we're going to go from endpoint to endpoint. And that's going to create that little line. So now we've completed the sort of outline of each slat. Right, so we've got top curve, bottom curve, left and right. So what we're going to do is we're going to take all of those curves, those 4 curves, and join them into a single polyline. So I'm just going to go, let's go in order. So let's grab our top curve first. And then in order to input multiple streams into one input, you hold shift. So I want all of the curves I'm going to join into C. So I've added my top curves. Now I'm going to add one edge, and then I'll add the bottom curves, and then I'll add the 4th edge. So now when I select this single node, you'll notice it selects all 4 of those curves. Now what we want to do is check to make sure that all the curves were joined properly. And the way to do that is if I come back to my original contour, you'll see that I have 106 resulting curves from the contours. So after I join all of these together, I should still end up with 106 total curves. But for whatever reason, I have 212. So it's not joining something in here. The quick fix for that is to just right click on C and click flatten. What you're going to notice is I'm now down to 106 polyline curves. This is a listing problem. I'm not really going to dive too much into it. It's a lot more advanced than what these scripts are trying to get into. But basically, if you hover over this and you look at the list of lines that are coming out, I've got 106 locally defined values. And you'll notice that each value is given a numeric number. So 0, 0, 0, n equals 1. 0, 1, 0, n equals 1. So if you hover over each one of these, what you might find is that the lists look somewhat different. Okay, and if they look different, see, you'll notice that these are just 0, 0, n equals 1, and these are 0, 0, 0, n equals 1. So that extra 0 that it's naming this with means that these curves are not going to join with these curves. It's just not going to happen. So by flattening everything, you're basically compressing that list into just a single numeric value. So I can show you what that looks like real quick. Pull out a panel. So I can pull this in here. So notice how each curve is defined by one of those values. Well, if I right click this and do flatten, it's going to freeze up for a second. Just give it a moment. It's going to flatten that list into something much simpler, right? There's just a single numeric value, and they're just called polyline curves now. So it's just a much simpler, more refined list. And I'm going to undo that because we don't want to do that at that location. But that's all that's doing. So just, if your curves aren't joining all together, they're probably just labeled or organized in a list differently. So once you have them all input into C, just flatten, again, right click, flatten, and that's going to resolve any of those issues. And now I've got 106 curves, which is what we're looking for. The last thing we're going to do is extrude these curves so our slats have some thickness to them. So what I'm going to do is create a boundary surface, which is create planar surfaces from a collection of boundary edge curves. Our boundary edge curves are going to be these polyline slats that we've created. So at this point I'm going to go back and turn off the surface, underlying surface, just so I can see what's going on. I'll plug in C into E. Okay, because E is asking for our boundary curves, and C is our defined polyline. So what you'll notice now is I've got this red surface at each slat. And then what we're going to do is extrude those surfaces in the Y direction. So double click, type extrude. I'm going to grab the first one, extrude curves and surfaces along a vector. So the surfaces I'm extruding, B, it's going to go into there. And now it's defined both an amplitude or a distance or an amount that they're extruding, as well as a direction. Now you'll notice I only have one input, and yet I need to define two variables. One variable being the distance it's being extruded, the other variable being the direction. So in order to do that, we grab what's called an amplitude. And this allows me to define a vector and a distance, and then it combines them into a single string. So my vector is going to be the Y direction because I want to extrude these along the Y axis. So I'll plug that into there. And then my distance, that's like 10.000. Now I know that's going to be way too long, so I'm going to set this back down to like 0.5. Plug that into A. And then what I'll do is I'll take B, plug that into D, and that's going to extrude every single one of those slats that distance. So all of these have some thickness to them now. And that's pretty much it for that definition. So you can take any surface, plug it into the first node here, and contour it, and then retrieve all of the slats for that contour. And you can laser cut these, you can create drawings from them, you can do whatever you want. But the great thing is that if I turn that surface back on, if I take that surface and I turn on my control points, so F10, if I modify this in any way, that whole definition will automatically update. And I don't need to recreate or remodel anything. Right? All of those slats, I'm just going to continuously update as I modify this model. So that's really like the main benefit to parametric modeling, is that once you have the definition set up, you can manipulate the underlying variable or surface as much as you want and get a lot of different iterations very quickly and efficiently. So the next thing we're going to do, now that I've got the slats taken care of, I'm just going to select all this stuff before it and turn them off. So I'm going to bake out that Grasshopper geometry into Rhino geometry so I can take Linework from it, or extract Linework from it. So I'll right click on E, bake, group, yes please, and click OK. What that's going to do is it's going to convert all of that Grasshopper geometry into Rhino geometry. Okay, and then what I can do is I can jump into, let's say, my front view. I've got that Rhino geometry. Close out of Grasshopper. You just double click and it'll minimize the window up here. Select this, type Pick 2D. And I want to make sure my hidden lines are turned on. My scene silhouette, which is the outside. You can use this little image preview up here to see what the lines are doing. I don't need tangent edges for this because I don't have anything that's curving. But I do want my scene silhouette on, and I want my hidden lines turned on. And I'll click OK. And it's going to create a line drawing from this view. And it automatically creates it in the top view. And now you've got that line drawing. And the nice thing is, it's kind of hard to see here, but it automatically layers everything for you. So you have hidden curves, you have visible curves, and then you have your scene silhouette, which is the outline. And when we export all of that into Illustrator, it'll maintain the layers so you can easily give it line weights and produce the drawing. And so you can take that drawing or that make 2D command basically from any perspective or point of view. So if you want to do like an axon of this thing, I can switch my camera and my properties to parallel, turn this into an Axon drawing, select it, type make 2D, click OK. Takes a second. Go into my top view, and it will have produced that drawing for me. Okay. So that's a really quick and easy way to produce these super high dense drawings. And then when you spend enough time with getting the line weights correct and all that kind of stuff, you can get these really interesting contoured images that explain hyper complex surfaces. So I'm just going to let these kind of hang out over here while we jump into the next one. Let's switch my camera back to perspective, and let's delete that because we don't need it anymore. Okay, so for the next one, we're going to get into how to fillet our slats so that they take on a sort of rounded look to them. So if you look at, let's say, this drawing here, we're going to go over just a little slight addition to the Grasshopper script that we just did, which allows you to round over the corners. So for something like this, I'm not actually creating a surface that's rounded. All I'm doing is taking each corner in our slat and just rounding it over by a certain distance. And we'll do that on this model here. So it's basically the same thing, but what you'll notice is that in the very beginning I've got this extra little node up here, which is this fillet command. Okay, so all I'm going to do is I'm going to copy and paste this. Select it all, copy paste. Just move these down. And we're just going to insert that little fillet command. And I'm going to do this on this surface so you can see what the differences are. So let's hide this. I'm going to come up to this guy up here. And I'm going to turn on the original contours. And I'm going to do the same down here. So I turn off the extruded elements and turn on the original contours. Okay, so right now they're the same, just because I copied and pasted that definition. I just re-reference the surface to the one next to it. And we're going to insert a fillet command. So we want to do fillet distance, which is fillet the sharp corners of a curve by a distance. So it's going to ask for our curve, which is our contours. It's going to ask for a distance. So we're going to type 10.000 and plug that in. And what I'm going to do is, what you'll notice is I'm getting rounded moments where I'm filleting those curves. So I'm going to turn off the original contours. And what you'll see is all of those sharp edges here, here, and here are all getting rounded over. And you can set this number. You can change it so it starts to die down so you can get a really tight fillet. Set it to 0 and it won't fillet at all. And then at some point you're going to reach a maximum. So you'll notice I'll keep going up and it stops filleting. That's just because you can't round over that curve anymore based on the length that each curve has. So I'm going to set it all the way to 10 so every corner is being filleted or rounded over as much as possible. Then all we need to do is, now that we have our rounded curves over, we're just going to replace all the instances where our original contours are streamed into. So this is going into our offset curve node, so I'm going to replace it there. So all I'm going to do is click and drag, and when I drop this in, it's going to replace whatever's already in there. So I'll replace it, and then it's going into our end node, so I'll replace it there. And then it's also going into our join node. So I'm going to, instead of replacing it by just clicking and dragging, I don't want it to replace everything. So I'm going to right click on C, disconnect that original contour. You'll see it highlights as red, so I'll click that. That'll disappear. Then I'll hold Shift and replace it. Now when I turn on our extrude node, it's going to extrude all of those filleted curves. So I bake this out. Rather than hard corners, you get that nice filleted look. So that's one way of creating a slightly more complex surface when you start to get rounded over curves. And then you can run through the same make 2D process to produce the line work for that. Alright, so that was these first two scripts, which is just a basic contour of a complex surface. Now we're going to get into this guy. In order to create the surface, all I did was drew out some curves, and then I lofted them from right to left. And you can get some pretty interesting creasing, and you get this kind of like waviness. Really what I'm going for, so you look at the ISO curves, which are these kind of intermediate curves on the surface. I want to get those to kind of taper as they go front to back. So that kind of set up that surface condition. Then what we're going to do is, rather than contouring, we're going to extract a different type of line work from this surface. I'm going to come up here, let's turn all these off, and let's hide these. This is actually a much simpler definition to create. Make sure I get the right one. Yeah, pretty sure it's just this one here. So I'm going to reference this surface, and before I do that, I'm going to disable that, because this gets kind of heavy. It takes a lot of computing power to do sometimes. So what we're going to do is I'm going to reference this surface into Grasshopper. So I'll type srf and I'll get this surface node. And I'll reference this, so I'll select the surface, right click, set one surface, and then hide the Grasshopper. I'm also going to hide those curves too, just don't need them. So I've got my surface referenced in Grasshopper. Then what we're going to do is we're going to grab what are called surface frames. So surface, we're going to get the surface frames node. I'm going to plug in, this is asking for the surface that we're going to divide, which is our surface node. And it's going to give us a bunch of planes. If these look way too big, you can come up to display, preview plane size. I'm going to set this to like 4. And those are going to look a lot smaller. Basically what this is doing is it's dividing the surface up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections in each direction. So there's kind of 10 rows and then 10 rows. And each one of these planes marks a point on the surface. And it's giving me the X, Y, and Z value of that point. So you don't see the Z axis because it's pointing up, but it's there. And what we're going to do is we're going to draw a series of curves through these points. And this is what's going to give us what's called our ISO curve, which is basically a curve that runs along the surface as it creases and manipulates. So first thing I'm going to do, I want to make the points more dense, so I'm going to add planes, and that's done by taking a slider. Now for this, I can't have half a point or half a plane, so I need to do a whole number value, so I'm just going to type 100 without any decimals, hit enter, and plug that in, and plug that in. So now I've got way more points to sample from. And again, if these are way too big, you can go up to display, preview plane size. I'm going to set this like 0.25. Enter. And then you're supposed to see I have a little plane on different points of the surface. Okay. And the intent is to draw a curve. So if I go into top view, it's going to be to draw a curve through each plane in one direction. And it does this pretty easily. Just double click, type curves curve. Construct the NURBS curve from control points. Our control points are going to be each one of these planes. So all you have to do is plug in your frames, which is each one of these planes. It's got a point at the very center of it. Plug that into V. And when I do that, it's going to produce this curve, or these curves, that follow along the deformation of that surface. This is not something you can do with just normal contouring. Okay, you'll notice if I follow these curves, as the surface bends and twists in different directions, the curves start to follow that deformation. Okay, and that's how you can get these really nice line drawings of really complex, smooth curvature. So I can take these curves and bake them out. So I can right click, bake, group, always group, because I don't want it to select those curves every single time I click OK. Then I can select that group of curves. And I've got this really nice drawing. I think these are on a hidden layer, which is why they look like they're dashed. So let's make those default there. Yep, there we go. And so you can create drawings, line drawings, that depict surface curvature. And you start to get, or you start to pick up on that curvature through not just how the curves are flowing, but also density. You'll start to get shadowy areas when you give this line weight, where creases happen, and then they start to open up where it's at the top of a curve or a more open area. And then those curves are going to be in 3D, which we don't want. So all you have to do is select them, type project to C plane in Rhino, delete input, sure. And that just projected those curves down flat. So I can now use that as a drawing type. And I'll move those over. Okay. Now if I wanted to convert those curves to geometry, what I need to do, one thing you can do is pipe them. So if you look at work from like Taylor Wu, and we go into their installations. So if you want to create something like this, you know, where they've done all of this contouring. This is actually, they're drawing lines between points that are divided on this frame. But if you wanted to produce that look, you need to pipe all of those so you actually get the geometry and you can render it. Let's see if there's another one. Something similar to this. Right, where they're contouring a complex shape. And then they're piping all of those curves. So that you can produce renderings and drawings and all that kind of stuff. And all you have to do, I'm actually going to turn my U and V. So this is how you define the density of curves, or the amount. So I'm just going to turn this down a little bit so there aren't so many. I'm going to grab a pipe node. I'm going to set my, so the curves I want to pipe, so put that in there. The radius is by default set to 1. Oh, I don't want it that dense, it's probably going to be way too dense. So I'm going to set this to like 0.25. Put the slider, put that in there. It's a little better. but I don't really want them to intersect, so I'm really going to turn this down a lot more. You get a much narrower pipe. Now, this is going to start to make Grasshopper run pretty slow sometimes, depending on how many curves you're piping and what the density is and all that kind of stuff. And then E under your pipe node, you can change this, the cap condition. You can make it a flat cap or a round cap. I just do flat. Basically all that is, if you zoom into the end of any of the pipes, that's a flat cap. If I right click and do round, it's going to turn it, it's hard to see, but it turns it into a round or rounded cap versus a flat one. And then you can bake out those pipes. So I'll right click, do bake, group, OK. Pull those over. So now I've got all those piped curves. And then I can do an Axon drawing of this. Switch my camera to parallel. Select those pipes. Do make 2D. Click OK. Let's see what that looks like. Top. And now I've got this nice drawing. And again, it seems to be putting a lot of stuff on a hidden line for some reason, so I'm going to select all of it. Switch it to default. And now that's a pretty good line drawing of those piped curves. Okay, so you have to decide whether or not you need to actually produce the geometry. If you're just doing a flat image where you just want like the top view of the curvature, then you don't really need the pipes. You can just extract the line work. But if you want to do something that's in Axon or something like that, it helps to actually convert the lines into some kind of geometry that you can then extract as an Axon view. So that's that type of curve creation is really helpful for extracting just a different type of way of explaining surface curvature. Okay, so now we've gone through that type of curvature. The last thing we're going to get into is contouring more three-dimensional shapes rather than complex surfaces. So I'm actually just going to grab these three items, pull them over. I'm going to start to delete some of this stuff because Rhino's getting a little heavy. So that stuff we can keep. We're going to mess around with creating some massing models. Again, if you're not sure how to create these, go back to the Rhino tutorials. They'll show you how to produce different kinds of massing models. But basically what we're going to do is contour these as a way of producing a drawing that explains a complex spatial condition through contouring methods. And that's what these last two guys down here are. So we can go with the first one here. And if I just preview the last node, what you're going to see if I just hide the geometry is I've sort of contoured these at an obscure angle and then turned each contour into sort of a slat or extruded piece of geometry. The idea being that you could like laser cut all of these and stack them and you would get a similar shape, something like that. You can also take really unique drawings of shapes like this as well. So let's just kind of run through how to do this. I'm going to turn this off. And I'll bring back a piece of geometry. I don't need any of this stuff on. Let's hide those so they're out of play. Okay. So the first thing we need to do again, like always, is reference our geometry into Grasshopper. So instead of using a surface node like we were before, this is now a much more complex piece of geometry. It's made of multiple surfaces that are all joined together, so this would be called a polysurface. And in order to reference polysurfaces into Grasshopper, we need to use what's called a B-rep. You can use B-rep, or the new thing, I guess, is just to use a geometry node. But I'm used to B-reps, so I'm just going to grab a B-rep. Select our piece of geometry, right-click, set one B-rep, and now that geometry is referenced into Grasshopper. Okay. The next thing we're going to do is create contours. So we're going to take the contour, grab our create set of B-rep or mesh contours, and we're going to reference our B-rep into our top input here. Okay. The next thing we need to do is reference the contour direction. Now we're going to do something a little different this time. I'm going to use this curve to define the direction of the contour. So you notice this curve is kind of angled. So that's going to be the direction at which it contours that geometry. So in order to do that, I'm going to reference that curve into Grasshopper. So I'll type CRV and grab a curve node and do set one curve. I'm then going to convert that curve into a vector. So I'll type vector, grab this little vector node, and plug curve into vector. And then I'll plug my vector node, which is our direction, into our contour normal direction. You're not going to see anything happen yet, but that's because we need to define a distance. So I'm just going to type 10.000, plug that into our distance, and we're starting to get our contours. I'm going to narrow this down a lot, just so we get a more dense contour. And what you'll notice is I can take this curve, because it's referenced into Grasshopper. If I rotate this curve, it's going to change the direction of the contours. Okay. Because the direction is again tied back to this curve in Rhino. So you can get some pretty unique effects that way. And then what I might do is I can, again, bake out those curves so I can use them for a drawing. Make sure it puts them on a normal layer. There we go. And then I'm going to grab those curves that I just baked out and the surface. Copy them over. Delete them from here. And now I've got this piece of geometry with our contours on them. And the cool thing that you can do is I can take this, switch to parallel, so I can do an Axon view of it. Select it all, type Make 2D, click OK. Switch to our top view and use that as Linework to produce a very dense image. Okay, where you get the line work from the actual piece of geometry, so you can extract the edges, and then you can also use those contours to create different kinds of patterns and things like that on top of your surface, and really like create some hyperdense drawings using this method as well. And again, everything gets layered. So you can give it different line weights and all that kind of stuff when you hop into Illustrator. Next thing we're going to do is I'll show you guys how to extrude those contours along a direction. We're going to use the direction of the line. So I'm just going to turn off those. So I want to give these contours some thickness, which means I want to extrude them perpendicular to the profile of each contour, which happens to match the direction of this curve. So what I can do is type extrude, and I need an amplitude like we did before. Amplitude, and so what I'm going to do is grab a slider, plug that into our amplitude. Now I'm going to use the same vector as our direction. Plug that in there. I want to extrude the curves. Plug that in there. So I'm going to extrude them way too far. So I'm just going to tone this down some so it actually looks like thin layers so that they don't overlap. And what you'll notice is these aren't capped. There's not a top and bottom. There's no thickness to them. So I'm going to grab a cap node, cap holes, cap all planar holes in a B-rep. And it's going to cap all of those holes. Okay. And then I can right click, bake, and get that geometry. And then I can do a make 2D of this and get something interesting as well, right? Where the geometry is now shifted or changed slightly from the base massing of the input. So I'll do a make 2D of this, click OK. Go to our top view, find that drawing. Then you get something like this. Slightly different version, same idea. Again, just using contour as a method for producing line work for more abstract massing models or more complex massing models. But you can see how Grasshopper enables you to really drive up the complexity of these types of line drawings. The interesting thing that is done by Shop, right, is that these drawings that they've produced tie directly into the method of fabrication, meaning these drawings help define the length of the slats. If any of the slats get milled, you can see in this image here they're actually using 1-to-1 scale drawings from this to lay out all of the slats. So there's a very direct connection between the way in which they're contouring and how that method applies to the fabrication of this actual piece. So you want to be thinking along the same lines while you're creating your drawings for these shapes. How does it help you laser cut this thing? How does it help you fabricate it in one way or another through this sort of like hyper layering process? For example, something like this probably wouldn't be a very good fabrication method because none of these pieces would stick together, right? They're all kind of floating in space. You could potentially stack these down here and kind of layer them up after they've been laser cut. what you would have to do is take each piece. I'd have this here. You can type orient 3-point, click 1 point, second point, and a third point on one surface, and orient it flat. Okay. There are other definitions that allow you to automatically orient all of these flat. I'm not going to get into them for this, but later on down the line, if at some point we need to laser cut these, or you guys want to laser cut something like this, we'll get into that. It's easier when you contour in one direction. Let's see if I can grab those contours. You know, if I turn on, I go back to one of the original ones we did, and I bake these out. Right, it's a lot easier to just orient these. Just rotate them sideways. And I can lay all these out to be laser cut, just like you would any other piece of geometry or model that you grab. But again, we'll get into that kind of stuff in a different tutorial. For now, this is really just about producing the drawing that shows these different kinds of effects. And again, the last one that's on here, we haven't really gone over this, but it's similar to the original, where I'm just filleting all of those sharp corners. So I just inserted a little fillet tool, which is how I got this kind of effect where it fillets over all of the sharp corners. You can get interesting techniques that way. So, a couple different methods of contouring complex geometry. One is through a straight contour, back to front. One is through isocurves, which is when you create or extract the lines that follow along the surface topology. And then a third way is by contouring massing models or three-dimensional models at different angles to produce those kinds of effects. All of which can be used in a Make 2D command, so you can produce flat two-dimensional images, which will allow you to produce imagery like this. I'm not going to get into Illustrator here. Again, you can go back to the other Rhino tutorials to see how to export these to Illustrator, mess around with the line weights, and export the image. So you can look at those on the other tutorials. Thanks.